All right, we're about to start Chapter 2 of the College Algebra textbook. Chapter 2, you can see, is on functions and relations. So what are we doing in this chapter? Okay, well, up to this point, what we've done is, in pre-algebra was all about learning the different types of expressions, the different types of variable operations, raising a variable to a positive or negative integer power, raising a variable to a rational power, and what that meant. So to understand this, we need to be sure that we understood what exactly a radical means, radical symbol, or what roots mean. Okay, and then you could combine any of these types of terms with addition, subtraction, multiplication, division. You could put them into like a fraction or something, or maybe inside of an absolute value, but that's it. That's it. In pre-algebra, we learned all of the types of expressions that we're going to be using throughout this entire course for the rest of the textbook. You might say, well, what about like exponentials and logarithms? I mean, there's not going to be all kinds of new expressions we're going to be learning in chapters 3, 4, 5, and 6. No. An exponential is just like we're going to see as a packaged form of raising a number to any kind of power like this. An exponential is just like, okay, you have any number as a base, and you can raise that. X can be anything, any real number, or really any complex number as well. But thinking about real numbers, it could be rational, it could be irrational, it could be an integer, whatever. So this is just the same thing as what we've already learned. And a logarithm is just the opposite of this. In the same way that like roots are the opposite of exponent terms, a logarithm is just the opposite of this. So in pre-algebra, we learned all of the different types of expressions that we're going to use throughout all of algebra, and how to simplify them, how to multiply them, add them, how to work with them across the board. Okay, now what we then did in chapter 1 on equations and inequalities is we put all of these different types of expressions into equations or inequalities. And we learned how to solve all of these different types of equations and inequalities. Radical equations, polynomial equations, so subsets of that are linear, quadratic, absolute value equations that contain these types of expressions, absolute value inequalities. Okay, but now the majority of the problems that we worked in chapter 1 were equations and inequalities in one variable. However, I did make it a point to note that if we extended any of these types of equations to multiple variables, in that case you would have what is called a literal equation or a literal inequality, then the mechanics of how we solve for like a certain variable or just manipulate the equation or the inequality are exactly the same. Whether or not you're in one variable or multiple variables, it doesn't matter. For example, here is a linear equation in 3 variables. Let's say I want to solve this for x. So in that case, I'm solving this linear equation in 3 variables. Well, okay, everything we learned about solving a linear equation in one variable extends no problem to this equation here. Let's add 5y to both sides and subtract 3z from both sides. Now let's divide both sides by 2. Done. There you go. I just solved a linear equation in 3 variables. Just to give you another example, let's solve this quadratic equation in 3 variables. So that means each term, this is a polynomial equation where the degree of, if you look at the degree of every term, it's going to be degree 2 or lower, with at least one term being degree 2 because it's quadratic. So this is degree 2, but this is also degree 2 because it's 1 plus 1 is 2. This term is degree 2. And then let's do right, so we can have linear terms, that's fine. And then let's do a constant at the end. Okay, so let's solve this quadratic equation for x. Well, again, the mechanics are exactly the same as how we learned to solve quadratic equations in one variable. The idea is whenever you're just manipulating an equation with multiple variables, you treat the variables that you're not solving for like they're constants. Even though they're not constants, you kind of treat them that way when you're manipulating the equation. So in that sense, let me come down here. To solve a quadratic equation, we would bring everything to one side and leave the other side equal to 0. Okay, so let's do that. But then let's also bring the x squared terms together, the x terms together, and the terms with no x together. So, okay, 4x squared, and then minus 3xy, and then minus 7x, plus z squared minus 2y minus 5 is equal to 0. Okay, so now since we're kind of treating y and z like they're constants, well, let's factor out the x squared and the x and just leave the constant, the non-x terms like it is. So, well, there's only one x term here, so there's nothing to factor out there. But now over here, let's take out a minus and then do 3y plus 7x. And then we've got z squared minus 2y minus 5. That's like the constant term is equal to 0. Okay, so now here you can clearly see we've got this ax squared plus bx plus c is equal to 0 quadratic form here, with a being equal to 4, b being equal to minus 3y minus 7, and c being equal to z squared minus 2y minus 5. So what you could do is you could apply the quadratic formula. Now, yes, this is messy. I'm not denying that this is really cumbersome and it's messy and you have to be careful and keep track of what you're doing. But I'm saying the mechanics are identical to what we've already done. So all you write out the quadratic formula for the solutions of x, and then you'd have a radical with, b squared, 3y plus 7 squared minus 4 times this. You'd simplify that, then you'd have to analyze and see, okay, for what values of y and z is this negative, and you wouldn't want to have a negative inside of the radical unless you allowed for that, then that's fine. And that would be x. That's what x would be equal to. Okay, and so now, but with that, where are we going from here? What's functions and relations all about? Well, okay, so as you might expect, the majority of scenarios where we're using algebra to model something in real life are going to involve more than one variable. And just to point out, the idea of what a variable or a constant is a matter of whether or not you label a certain quantity as a variable or constant. So, for example, we worked applications of quadratic equations that were based on a kayaking trip, the length of time it took to, or what was it, the speed of a kayak in still water based on different information given. And we solved this quadratic equation in one variable to get the quantity we were looking for. Well, maybe you might want to say, I'd rather not just make a certain input like, let's say, the current of the water. So we were just given the current of the river as something, I don't know, 3 miles per hour. Well, maybe we want to make that a variable because the current of the water can be different. Maybe we want to turn that into a variable. Maybe we want to make the speed of the kayak in still water, so the speed that you paddle with, maybe we want to make that a variable as well. So you can kind of compare, okay, based on the current of the river and how much effort I paddle with, what's the different times that are going to result from that? How long is it going to take me to make the kayaking trip? So you want to see the relation between different variables. You don't want to just have to look at one case of one current and that's it. Now, but I'm not saying that sometimes that's not valid. If the current is like always close to 3 miles per hour, no matter what, unless it's like some extreme weather day, well, then you leave it as a constant. But maybe you don't want to do that. Maybe that's not really how it is. In a lot of cases, it's not like that. It's variable. Okay, and so since the majority of real-world problems that we're trying to model mathematically are going to involve more than just one variable, then you can see that in a lot of cases, we're going to be dealing with equations that have multiple variables. And so even though we understand after going through chapter 1, we understand how to manipulate any kind of equation in any number of variables like we just did here, we still want to be able to be working with any equation with multiple variables. So let's come back to, what was it? It was something like 8 minus 2y plus z over 3. We want to be able to have an equation like this and have the ability to really analyze how these different variables are related to each other. Because we know that as y changes, x is going to change. As z changes, x is going to change. But it's not just y and z being related to x. They're all related to each other. So we want to be able to really analyze the relations between multiple variables in some system. And that's one of the main things we're going to be focusing on in Chapter 2. And one of the main ways that we do this, that we study the relationship between variables in an equation, is we use a graph, a 2D or 3D graph, because you can put one variable on each axis, or in 3D, you can put a variable on each of the three axes. And so what we can do is we can have an equation like this, okay? And what you can see is that you can, once you pick an x and a y, then we're left with an equation. In this case, it would be a linear equation in one variable, and we can solve for z. So you can pick an xy on this xy plane, solve for z, and now you plot a point. And you could do this if you just have an equation in two variables as well. Like you pick an x, if there's an equation in two variables, pick an x, solve for y, or pick a y and solve for x. Here we could pick x and z, solve for y, or whatever. And you do this with a lot of points, and you have like a graphical illustration of how these variables are related to each other, which is really useful. So like in essence, graphically, what you're looking at is different solutions to this multivariable equation that you have. They're all solutions. They all satisfy the equation, but you're looking at these different circumstances. Maybe you have an equation that relates profit to cost or expenses or something, and you want to find the most ideal solution, that perfect balance of price, expenses, etc., that maximizes profit. Okay, but now there's a lot of circumstances where we will model something with math that involves more than three variables, in which case, how would we visualize that graphically? Because visually, we can only think up to 3D space. Well, when you get past three variables, it's hard to have any kind of visual representation of the relation between the variables. But if we master our understanding of equations with two variables and equations with three variables, how they're represented graphically, this is going to be extremely useful for understanding how any equation with any number of variables behaves, because we can kind of abstractly extend these concepts to multiple dimensions, right? So if we think about, maybe we could shift a graph along the y-axis or along the x-axis here. Well, if we had an equation in 5 variables, then you can kind of think about, okay, I'm shifting along the 5th dimension. You could abstractly think about that. So it's going to be really helpful to study these equations in 2 and 3 variables graphically, even though in general, for equations with many variables, you can't really think about it that way. Okay, so now you have a sense of the idea of relations that we're studying. Right? Any equation with more than one variable you can think of as a relation. It's relating variables to each other. Any equation or inequality with more than one variable, then that's like a relation. Those variables are related. You do something, that you change one variable, it affects the other, and vice versa. But what's this function all about? What are we talking about functions here? Well, okay, if you really think about it, and it's interesting once you get a sense for this, of how prevalent this is in your everyday life. But the way that everything around you, including yourself, including machines, etc., the way they fundamentally operate is that they take in a bunch of inputs, multiple inputs, or just one input maybe, but then they only output, the output is one thing. Like an ATM machine, you can't have the ATM, you can't give it an input and all of a sudden it's making decisions, and then it decides to give you, based on a certain input, it's told give $20 and $60. That doesn't make sense. It has to, when it's all said and done, it has to have one output. Okay, and so when it comes to all of these different expressions that we've created in pre-algebra, if we want to use those to solve real world problems, to model things in the real world, the majority of the time, what we're going to be doing is taking these expressions, mixing them together, multiplying, adding, dividing, just joining them together in different ways to create what's called a function. And all a function is, it's just a subset of a relation. So a relation you can think about as just any equation with two or more variables, no matter what the equation is. So it just relates these multiple variables. You can think about an equation that way as a relation. A function is a special type of equation to where it's like you've got this one variable on one side of the equation alone. And then you've got this entire expression over here that doesn't contain this variable at all. Maybe there's multiple variables over here, but it doesn't contain this variable. And the whole point of this is that the way this works is, so you're going to input, it's kind of like a machine. You're going to input one or more variables and then simplify, and you're going to get one output. Unless maybe like the quadratic formula, if there's like a plus or minus in there, then it wouldn't work out that way. But the vast majority of the time, any expression, when you input something, you just get one output, right? There's very few cases where you see something like a plus or minus in an expression. In general, you're just going to have some expression with one or more variables that are different than y or z or whatever this is, to where you input one or more variables, you simplify, and you get one output. And so let's say you're inputting x and z. Then because it's a function, because every single input corresponds to just one output, you can put it into this like machine form where you can say f of xz. This function of x and z, you input x and z, and it outputs this single value. Okay, and again, functions are going to be used the majority of the time to apply algebra in circumstances. If you're trying to figure out how much do I need to run today, how much money do I need to spend to do this, do that in my business, you want to be able to give inputs into some mathematical model you wrote, and it gives you an answer. It doesn't tell you more than one answer. It tells you, okay, you need to run 3 miles. You need to spend this amount of money to, this is what you need to do. That's what machines do. At the end of the day, you give it inputs, and it might make decisions in the intermediate, but when it's all said and done, it's going to give you one output. Okay, and so with that, one of the things that we're going to be doing in this chapter and even in the upcoming chapters is we're going to be taking some of these basic expression categories, like the polynomial, the linear, the quadratic, the radical, the rational expressions, etc. We're going to write them as functions. Most of the time, just functions of a single variable to start, but it still is, in essence, a 2-variable equation. You just have like y on one side and some expression of x on the other side. But we're going to be writing it, you can write y in this function notation. You just have this expression of x over here. You have a rational expression, a polynomial, linear, etc. And we want to fully study this function, study its graph, for example. The key points on the graph, just the different features of this kind of expression. So in practice, you could take something like a quadratic function or a rational function or a polynomial function or some combination of those, and you'll have a sense for how it behaves, the key points on it. So that's the idea of functions and relations. That's what we're getting into in this upcoming chapter.